switching. What it is? Switching is moving the packet using MAC address. Moving the packet using layer 2 address. Layer 2 address. Moving the packet using layer 2 address, MAC address, not based on IP address. Now you see, if you want to move the packet using MAC address, all the devices must be in same network. If you want to move from A to B, A and B should be in same network. Moving the packet using layer 2 address. Yeah, this is what we call it as switching. So this is very important to understand. You have to know that the decision for the exit interface on the switches are not based on IP address, but based on MAC address. For example, you see, I'm drawing switches, not the routers. And this has got 10.0.0.5 and MAC address is GGG. Another computer 10.0.0.4 MAC address HHH. And I have a switch, interconnection between the switch and 10.0.0.3 A and 10.0.0.2 B and 10.0.0.1 CCC. Now you see all these computers are in same network called 10. To communicate between these devices, do we need a router? Do we need a router to communicate between these devices? Answer someone. Anand? Do you need a router to communicate between these devices? No, because they're all in same network. Same network devices, PCs can route it. Your computer itself can route the packet to the destination. With the help of ARP, they learn the MAC address of the destination and they will start moving the packet to the switch, and switch will move the packet to the right direction using MAC address. That is what we call it as switching. For example, when you say ping 10.0.0.5, the packet will be like this. The source IP is 10.0.0.2. The destination IP is 10.0.0.5. The source MAC address is BBB. and the destination MAC address is GGG. How it knows GGG? From the ARP table. Now, when this packet goes to the switch, switch will only see the destination MAC address. It is GGG. Both GGG and HHH are binded to this port. And GGG is here, binded to this port in the switch. HHH in this port. And those two MAC addresses of switch 2 are learned in this port because this is the way the traffic will come in from these two. So this switch 1 knows that GGG is on this port. Both GGGR and HHHR are in this port. Let's say F03. It is in F03. It knows. It learns the MAC address and it knows it in the MAC table. So the packets are now not going to this direction or this direction. They're only going via this direction because that is where GGG lies somewhere. The packet is sent out via F03. And it goes to S2. S2 also checks that MAC address of the destination packet, the packet's destination MAC address, and knows that it is on this port, not on F2, F3. So it pushes the packet this way out. And the packet now reaches. When the packet reaches the computer, computer will first check the MAC address. Is the destination MAC address my MAC address? Yes. Is the destination IP address my IP address? Yes. You see? Only then it will accept the packet. So the MAC address plays a role in deciding. Switches uses the MAC address. MAC address plays the role in decision making, not the IP address. This is what we call it as switching. The switches never bother about the IP address of the destination. It will only see the MAC address and forward the packet to the destination. And the computer which is receiving the final destination computer will see all. Will see MAC address, will see IP address, will see port number, will see everything to process the packet. But these intermediate devices, switch 1 and switch 2, they only focus on the MAC address to decide the packet's direction. Is this clear? Anand, are you there? Why can't you respond? Okay, fine. If you understand, good. Now let us learn the three main functions of a switch. The three main functions of a switch. There are three main functions a switch does. Number one, They listen and learn. What do they listen? Every port of a switch will listen to the incoming source MAC address and learn it into the MAC table. For example, the same picture. Yeah. Now, I told you the switches will listen and learn MAC address. Here, how the switch knows GGG and HHH are connected to F03. How? When the first computer from HHH comes, like this, when it comes from here, this port is listening. It learns that HHH is on that port. Likewise, when this packet is coming this way, the packet source address is GGG, so it learns both. It can learn any number of MAC address on a port. Here is the example. You see here between two switches, when you have an inter-switch link, that ports will learn more than one MAC address. Whereas this port, let's say F01, and this port F02, and this port F04, they don't have more than one MAC address to learn. When this computer sends the very first packet, it learns. Let me draw here. In the MAC table, it learns that a BBB is on the port F01. And when this PC sends the first packet, it learns AAA is on F02. Likewise, when this PC sends the packet, it learns CCC on F04. Likewise, when these two PCs communicate, it says GGG and HHH are on F03. This is how the MAC address against the port learned. Likewise, here in this switch, you will see AAA, BBB, CCC on which port? This port. Let's say F01. And then this is F02, HHH. And GGG F03. This is what the switch will do when a packet is received. The very first job is to listen to the incoming source MAC address of every packet on the port, learn those MAC address into the MAC table. Very first thing the switches will do, listening and learning. Listening and learning. Secondly, let me draw a fresh picture. And this is S1, and this is S2. And let's say the MAC address is and I want to tell you that switches will also have one MAC address for all the ports. Let's say the MAC address of this one is alpha, 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 and of this switch is beta, beta, beta. Now I would like to name these ports F0, F1, F2. Usually it will be F0/1, F0/2. I'm just making it simple. This is F3, F1, F2, F3, F4. And I would like to call this as F4. Switches won't have 0. It'll always have 0/1. From 1 only it will start. That is how the operating system is designed. That's not a big matter to discuss. Now, after learning how the MAC address will look like, the MAC address of this switch and this switch right, it'll be like this. BBB is on F1, CCC on F2, AAA on F4, and alpha, 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 comma, D, 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 comma, E, 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 comma, F, F, F. All these are in F3. Likewise, on switch 2, beta, comma, BBB, CCC, AAA. These are on which port? Anand, you tell me. Which port? F1, correct. F1. On DDD is on F2. EE is on F3. FFF is on F4. So after learning MAC address, your MAC table, when it is fully updated, we have something to learn. So far, what we have learned is only listening and learning. The next thing what you are going to learn is forwarding and filtering. When will the switch forward, filter? When will the switch forward and when will the switch filter? Forwarding and filtering. Switches forward, filter. Same picture. Let's say the packet is coming from BBB and it wants to go to EEE. Now, what switch will do when this packet is received on this F1, first it will check whether I have learned or not. Yes, I have learned. Secondly, where do I need to forward? What is the destination? Do I know this destination? Yes, I know. It is on F3. It forwards. It forwards. Now, when will it filter? Let us assume this as a hub. This is not a switch. Let's assume this as a hub. Hub is a layer 1 device. They don't learn MAC address. Now what will hub do when it receives this packet? It will not read the destination and all. It will simply, whatever it receives, it will forward it to everyone. It will forward here, it will forward here, it will forward here. That is what we call it as broadcasting. Hub will always broadcast because they don't learn MAC address, they don't know who is where, so it will send everything to every port except from the port where it is coming. It will forward to all other ports. Now this packet goes to switch 2. What will switch 2 do? Will it forward or will it filter? Switch switch to is a switch. It's not a hub. It will definitely check whether I have learned B or not. Yes, I have learned B. Then it will check, do I know this destination? Yes, I know the destination. What it is going to do? Forward. The switch is forwarding because it knows that the destination is one of the port in the switch. Now let us focus on the filter. Instead of BBB, now you are going to CCC. CCC. It's a hub, so hub will do broadcasting. So it will send to this one, and this one. The packet that went here with this CCC will be filtered. Why? When switch receives, it checks the source. Do I know source? Yes. On F01. Do I know the destination? Yes. That is also in the same port. Why will I forward? Why will I forward? Both the source and destination are in same port. Why will I forward? Where should I forward? I can't forward anywhere. So it will filter. It will filter this packet. It will stop the packet sending further. It won't take it in. It will simply filter. The packet only goes here and it gets response. So here a filtration happens. So switches will not only forward, it will also filter. That's the point you should know. When the source and destination are in same port, switches will filter. Is this clear? It will filter when the source and destination are in same port. Next, switches will also flood. We just learned that hub will flood, but I tell you, switches will also flood whenever it receives unknown destination. Whenever a packet with unknown destination is received, switches will flood. For example, in this PC, a packet is generated with a source of BBB and destination of KKK. Let's say the KKK is somewhere here. Very old PC, long back, the switches learned this KKK, but later they forgot. Switches forgot the MAC address because that's a buffer. It will refresh if the communication don't happen. The switches will forget MAC address if you didn't communicate for a long time. But this computer remembers. But switches have forgotten KKK's location. This PC knows that there is a destination called KKK. So when this packet hits the port of S1, it checks the source. Do I know the source? Yes, I know. Do I know the destination? I don't. Now it will flood. It will flood. The flooding goes to this and this, and this, and this, and this, and this, and this. And the only person that is going to respond to this is this guy. When KKK responds, all other will drop. When KKK respond, the source will be KKK and the destination will be BBB because from there only it was coming. Now, this, when it enters this, it learns that KKK is connected via F5. And when this packet enters this port, it also checks the destination. Destination is BBB, so it forwards the packet via F1. When the packet hits here, it learns that KKK is connected on F3. And then when it checks the destination BBB, it knows that I need to forward it via F1. The packet comes back. You see, this is how a new learning happens by flooding. So learning is also by flooding and learning. It floods and it has learned. If it didn't flood, it will not know where is KKK. So flooding also happens on the switch, but not all the time. Hub will flood all the time. Hub floods all the time. Switches flood only if the destination is unknown. These are the three main characteristics of a switch. Number one, listening and learning. That's number one. Number two, forwarding and filtering. Number three, flooding and learning. Yeah. So any question on this three main functions of a switch? Switches move the packet based on MAC address, not based on IP address. That is why we call it switching. Layer 2 communication. Switches, they listen, so they no need to flood. Whereas hub never listen, never learn, so they don't know where is who connected. As a result, they need to flood all the time. That is why we call that as layer 1 device. They don't deal with MAC address. Hub don't deal with MAC address. Now, before we move to any other topic in switching, I also want to make this one point clear to you. There are two types of layer 2 device. Switch, bridge. Both deals with MAC address. Both learn MAC address. Both does what I have explained so far. Forwarding, flooding, learning, filtering. Both do the same job. That is why it is layer 2 device. Then why two different names? The answer is this. See, this is one CCNA question. What is the difference between bridge and a switch? Similarity is both are layer 2 device. Similarity is both listen to the MAC address, incoming MAC address, source MAC address, learns the MAC address. They forward, they filter, they flood when the destination is unknown. All those things are similarities, should not say similarities. When they are saying, when they are asking you the question, what is the difference between bridge and a switch? Talk the real difference. The real difference is this. Switch is the hardware based device. Whereas bridge is the software based device. Hardware based device, software based device. Now, what is the meaning of it? Switches have multiple ASIC chipset for learning and forwarding job. See, every device will have a CPU, processor. Here you have CPU, along with CPU you have ASIC chip to do the load sharing. Here only the CPU have to do all the load, all the functions. Here the learning and forwarding decisions are made on ASIC, not the CPU. As a result, CPU is free to handle more traffics. So this can handle more traffic. Comparatively less. Comparatively less traffic handled. So as a result, you will have less number of ports on this box. All right, less number of ports. Here, more number of ports. You see, switch is the hardware-based device. Why? Because you got more hardware like this, ASH. See, both are physical box. Both are hardware. Both are a box, hardware box. Both look similar, sometime similar, but the amount of traffic that the switch will handle is more than bridge. Because switch has got more additional CPUs called ASIC. So more traffics can be handled, though it looks similar box. Same time, sometimes both may have same number of ports, but inside switches got more ASIC, so they can handle more amount of traffic, more throughput than bridge. Bridge is a software-based device because the only operating system that runs using that one CPU have to take care of every function. Whereas here, this ASIC hardware takes care of functions like learning and forwarding. That is why switch is hardware-based device, bridge is software-based device. Nowadays, in the enterprises, we don't have that software-based bridge. We have only hardware-based switches. But the domestic switches, which is there in the house, in your house, if you have a switch, D-Link switch, they're all software-based. Any question? Okay.